Said we're doing exercise 14H today. We're skipping forward a little bit, so we haven't done 14G. So some of the examples, particularly the ones on the first page, on page 503 of the textbook for exercise 14H, will look a little weird because we haven't done wave functions. But we will do that hopefully later in this lesson, or we'll introduce it next week, whichever one works. So the idea is trigonometric equations. The whole point is that if I've got sine, cosine, tan, whatever, what is the angle it gives us that we can solve to get a certain value? We know that sine is the y value. We know that cosine is the x value. So what certain values of the angle, whether it's in radian degrees, gives me a value that is what is provided. So I'm going to do an example and then we'll go through it. So the idea is, let's say I've got sine, let's do cosine actually. And you're going to heavily look at the exact values table because this is a question, or this is a type of question that you can do in calculator really easily. But the idea is that you need to be able to do it by hand to understand what's going on. Also, I'm not going to give you a calculator for this. So let's say we've got cosine of theta equals to root 3 on 2. And I'll give you guys a heads up. This is something that's going to be on, as in this topic is something that's definitely going to be on the test. So it's very important that you understand how to do this. So let's say I've got cosine theta equals to root 3 on 2. The first step, oh sorry, I've got the domain. The domain is 0 degrees to 360 degrees. So in other words, first 4 quadrants, that's it. What angle, what special angle do I have that gives me cosine of that, whatever angle it is root 3 on 2? So you can go back to your table. I personally don't like the table. Let's do this thing over here. 1, 2, root 3, 60 degrees, and 30 degrees. I'm not going to explain it too much just because we've done it before, but this is a special triangle. Now I'm thinking, well, adjacent over hypotenuse, that is the formula for cosine. Remember, oops, that's not it. We've got C equals to A over H. Right? So A in this case would have to be root 3, and H needs to be 2. So if I look at it from this angle over here, what would my cosine be? Well, it'd be adjacent 1 over hypotenuse 2. So that's not correct. So let's go about the other way. So I say, well, if I look at from this direction over here, and I say cosine of 30 degrees equals to adjacent, which is root 3 on 2, root 3, sorry, over the hypotenuse, which is 2, which gives me the angle, the value that we've actually got in the question. So I know that theta can equal to 30 degrees. Okay? Does that make sense so far? Yeah. So what I've done is I've referred back to my special triangle or my exact values table, whichever one you prefer, and I've identified that theta can be 30 degrees in order to get this root 3 on 2. But the reason I'm saying can be, not has to be, is because there are other values that give us the same answer. Because remember, it's a circle. If I keep going around in my circle, you will end up, because remember cosine's x value, right? Let's say root 3 on 2. Actually, can someone put root 3 on 2 in the calculator and give me in decimal places? Thank you. It should be obviously between 0 and 1. 0.86. That's enough, thank you. 0.86, yep. So 0.86, if I do my unit circle here, that would be about 0.86. And we're saying that's root 3 on 2, right? So about 0.86. Now, if I keep going through the circle, where is it going to give me another positive value of cosine? Because remember, in the question, it says positive root 3 on 2, not negative root 3 on 2, but positive. So which quadrant? You know, in the first quadrant, it's going to give me a positive value of cosine or x. If I keep going around, we know that if it gets to this point, that's going to be a negative x value. So I don't care about that one. I'm going to keep going all the way around here. In this quadrant, it's also going to be negative. And you end up being over here, where this point right there will give me also 0.86. Any questions about that? No? Okay. With that in mind, I know that I need to get to that point right there. Now, remember the idea of the symmetry. We always go from this axis here. So we start from this point and we go to that x-axis and we either add or take away. Okay? So if I'm trying to get to this angle, I know that this angle here, how many degrees is that? 30 degrees, thank you very much. 30 degrees. If I'm going to this angle down here, I know that's 30 degrees. Now, why can't I say negative 30 degrees? Why is that not an answer? What's our domain? Sorry? What's our domain of theta? Yeah? 0 to 360. Now, if there was no domain, negative 30 degrees is absolutely a viable answer. But because our domain specifies it has to be between 0 and 360, we have to find another way to get there. So the other way to get there is if I go, like I said, all the way to 360, and then I take away and go backwards 30 degrees. So in other words, it's 30 degrees, or the other answer is 360, take away 30 degrees. And so theta equals to 30 degrees or 330 degrees. Do I have any questions about that? Yes.
Do we have to give both answers, or can we just give
Absolutely, you have to give every answer that fits. So I've never seen a question of this that doesn't state a domain. So you get a domain, and that domain is typically going to be, for example, between 0 and 360 or 0 and 4 pi or something like that, very reasonable. And you have to figure out, well, if I keep going around the circle, forward or backwards, positive or negative, how many answers can I get? And when we go back to the idea of 14G, which we haven't done, you'll see a way that we can actually identify how many answers there should be. But the idea that I've gone with this is I've seen that, well, cosine theta equals to a positive number. So there should be two answers because it goes through two quadrants that are positive, right? Where cosine is positive in both the first quadrant and the fourth quadrant, because remember the asterisk aspect. Anything else? Any questions? Yes, Sam.
So, since it said if you just work 330,
Yep.
would you be able to understand that? Like,
What do you mean if I just wrote 330?
because the fact that you put 360 minus 30.
Yep.
It shows
Oh, so you're saying if you just cut this line out and you just wrote this one?
Yeah.
Yep, that's valid as well, as long as I understand where you got from there. So you can't just write from the get-go, just write 30 or 330, because I need some working out. Good question though. Anything else? No? Okay, let's do one more example before we get to the more difficult one. I apologize, I know this is already a little bit complex. So let's say I have let's say I have sine theta degrees equals to 1/2. Same domain, so I'm going to write 0, theta and 360. Now, what's the first thing I do? Actually, no, I'm going to change the question. Let's do half, negative half. All right, what's the first thing I should do? Yes? Sure, let's find the quadrant that gives us a negative value. So which quadrants give me a negative value of sine? Sorry? 3, 4, yeah, that's correct, 3 and 4. So we know that bottom two quadrants, 3 and 4, have to give me a negative value of y, or in this case, sine, right? Makes sense? So the next thing you're going to find is a reference angle. Right? So reference angle, what we did earlier, same thing. We said, well, 30 degrees over here, cosine of 30 degrees equals to √3 on 2. Now it makes sense that I say, no matter how I use this triangle right here, there's no sine or cosine, whatever, that's going to give me a negative value, right? Because none of the numbers are negative. But we can use it to find a reference angle so that we can find the actual correct angles, if that makes sense. Okay? And if it doesn't make sense, let's go through it. So I'm going to ignore the negative in front of the half for a second. I'm just going to focus on the half. So what value of theta, gives me sine theta equals to 1/2. I go back to this idea. Sorry, what was it? 30 degrees, perfect. If I look from over here, my opposite is 1. My hypotenuse is 2. And remember that we have sine equals to O/H. So the angle is going to be 30 degrees. So sine 30 degrees equals to 1/2. Are we okay with that? Yep. 30 degrees is my reference angle. Okay, reference angle. Apologies for the bad handwriting. If I go back to this, 30 degrees is not an answer that I can put into the actual question where sine 30 equals to negative 1/2, because it's not negative. So remember the idea of quadrant 3 and 4. Going back to me drawing a very poor unit circle, I know that it has to be in the bottom half in order for it to be a negative y value. So I know that this value here, 30 degrees, is going to, that point there has a y value of 1/2. So I need to find this point there and also this point there. Does that make sense? Yeah? So I need to find those points. I know that this one is right there. That's obviously not going to be a negative number. The y value is above the x-axis. So let's go all the way around. Can I go this way? Why not?
It's going to be negative.
Perfect, the domain. It's outside of the domain. It has to be positive and it has to be less than 360. So I'm going to go the other way around. I'm going to say, what's the angle from here to there? So, thank you very much. Theta equals to 180 degrees plus, and remember that is 30 degrees. That's our reference angle. And so we say, well, that's not a plus, that's an equals. There we go, plus 30 degrees. What about this other one over here? How do I find that? How do I find that? Well, I have to go all the way to 360, right? Because I can't go to this axis there and then add 30, because that's not correct. We have to go all the way to the x-axis, like this one here, over here, and then we go back 30 degrees. Okay? So in other words, I go 360, take away 30 degrees. We okay with that? Yeah. So theta degrees equals to 180. What's 180 plus 30? 210, thank you very much. Or 360 minus 30? 330. That's not 330. There we go. Does that make sense? And do I have any questions? And if you have questions, it's perfectly fine. It's a very difficult thing to go over. Is that a question, Si? No? No? Okay. I'm assuming we're generally okay with that. I'm going to introduce the next little bit of spanner in the works. Let's say I have sine of 2 theta equals to negative root 3 on 2. Where theta is an element of negative pi. What does this mean? What does that mean? Sorry? Sorry, what? What does this mean right here? It's just the domain. It's just a different way of writing domain. So it's just saying theta is an element, or theta has to be, a part of negative pi to pi. So if I'm saying that in degrees, what's the domain? Negative 180 to 180. So if I'm drawing my unit circle again, one day I will draw good straight lines. That day is today. Okay, so if I go from here, I know that has to be this way or this way. That's the biggest domain. I can't go any further than that. There is no 360. Okay? So with that in mind, let's get started. So if you're presented with an equation like this, the first thing you have to do is you have to substitute 2 theta with something else. We can't just say, well, 2 theta equals, because it gets really confusing. So let's say, let's 2 theta equal to x, in which case I would have sine x equals to negative root 3 on 2. Are we okay with that? Yeah? It's very similar to what we did with our quadratics. Right? Where we had to substitute a value in order to solve it. So I've got x, but with that in mind, because we know that x is double theta, right? We're agreeing on that? X is double theta, then our domain has to also double. If x is twice as big as theta, then it makes sense that our domain of our x is also twice as big as theta's as well, right? So if I'm going from that, I know that x is an element of, twice of negative pi is negative 2 pi, as in 2 times, sorry. So twice of that is negative 2 pi, and it goes to 2 pi. Are we okay with that? Yeah, and they're both square brackets. I just don't know how to draw straight lines. Okay. From that, let's continue. So I know that sine x equals to negative root 3 on 2. Now we're just treating it as we did before. It's a negative value, so which quadrant is it? 3, 4, thank you very much. Because it's negative y value. With that, let's go back to our special triangles. And once again, if you want to use your table, that's fine as well. I just prefer the triangles. One day I will learn to draw straight triangles. That day is today. Okay, so this is, then we're working with pi and radian, because that's what our domain is. So we have to give an answer in radian. It's a very important note. If the question is in degrees, so it says 0 degrees to whatever degrees in the domain, or it states that this is certain whatever it is. If it's degrees, you have to give degrees. If the question's in radian, you have to give radian. This question's in radian, so I'm going to give it in radian. So